10 through 15. And we'll just keep the camera running for that, and then we'll have them in small blocks at 5, because these are true false. Number 10. Okay, so we're on. Okay, this is for what are the true false parts of the problem. So these are the comprehensive problems. And number 10 is if Q is greater than K, then the forward reaction is spontaneous. And is that true or false? And now, in order to answer this one, we got to recall that what is the request for spontaneity? A process is spontaneous under what condition? If what? The free energy is
0.
less than 0. So if it's less than 0, it's spontaneous, and that delta G is equal to RT times the natural log of Q over K. So if Q is greater than K, then this is greater than 1. And the natural log of a number greater than 1 is positive. So that means that this is false. So delta G is greater than 0, therefore, and therefore, delta G greater than 0, therefore, false. So now for number 11. Okay, now number 11 is for every process, the heat transferred is path independent. And this goes to what types of functions are path independent? State functions. And we, as we showed in the one case of with the Joule cycle, that
Heat and work are not.
that
state.
heat and work are path dependent,
Yes.
and they're not state functions. And since it worked there, and we used physical laws to show that, physical laws know no exception. Therefore, it's true in every possible case. And Q is definitely the Q is not. Heat is not a state function. Therefore, this is false. Okay, now for number 12, if delta G is less than 0 for a process, and it's exothermic, and by the way, I put in parentheses, that means the delta H, because the thermicity refers to the enthalpy, that delta H is greater than, no, it's endothermic. And that means delta H is greater than 0. If it's exothermic, delta H would be less than 0. So just to remind you, I included that in. Then delta S is greater than 0. This particular problem is going to be one of those where we have to recall that if I have delta H and delta S, delta G is less than 0 when, and if we had a case where I recall that delta G is equal to delta H minus T delta S, to take this into account. So we know that delta G is less than 0 and that this is positive. Therefore, this can't be less than 0 unless delta S is positive, because the temperature is in Kelvin. That is positive definite. It cannot be negative. There's no such thing. And so that requires that delta S be greater than 0. So delta S has to be positive. And therefore, this statement is true. Okay? And now 13, which is the one after 12, and the one before 14, is for every cycle, the heat transferred is equal in magnitude and opposite in sign to the work performed.
True.
Yes, that is true. But let's go up real quickly and explain why. Recall from the first law, delta E cycle and delta E for everything is equal to Q cycle plus W cycle. And for every cycle, the change in energy is 0.
Right.
That's a characteristic of all cycles. We use the Joule cycle, but it's going to be true of the Otto cycle, the Diesel cycle, the Carnot cycle, and any other cycle you want to come up with. And therefore, Q cycle equals minus W cycle, which foreshadowed and led us to a lot of the thermodynamics, which was going along the way of finding the maximum work, which, because of this fact, led to having the largest temperature difference between the hot stage and the cold stage, which led Carnot, studying the efficiency of every process, to find that for every cycle, that Q over T, the heat transferred over the temperature at which it was transferred for the hot stage, plus Q of the cold stage, the heat transferred from the cold stage over the temperature of the cold stage, was equal to 0, which, because we had something that for every cycle was 0, meant it was a new state function. Carnot didn't recognize that, but Rudolf Clausius and Lord Kelvin and others who developed the thermodynamics recognized that that's a new state function, and entropy was born. And that was the empirical basis of upon entropy was based. And then Ludwig Boltzmann came along with this statistical approach, which provided a theoretical explanation that also brought about the development of the kinetic molecular theory of matter. So all of this is foundation material. So this is indeed, therefore, true. Well, that was a rather long-winded true-false answer. So I am somewhat long-winded and pedantic, but this is probably a good affliction in this case. Can somebody answer that?
Ice cream man, ice cream man.
That's what it sounds like, the ice cream.
It doesn't sound as authentic as the old London Tower.
Yes,
Is that Little Ben?
Little Ben, that's
This is Little
Ben.
Ben.
Too bad Ben's not here today.
I know.
I think he's out shooting. We're shooting,
Right.
he's shooting a different time of it. Okay, in practice, all processes are reversible. Is that true?
No.
No, that is absolutely the opposite of true, which would be false. Because there is no reversible process because there exists this thing called friction, which would prevent the mechanical processes we've been discussing from being truly reversible. And a little later on, when we get to electrochemistry, we're going to find that, there are some processes that would seem to be a lot more reversible, but indeed, there's this thing called resistance,
No.
which is going to frustrate us in our attempts to have perpetual motion. And so this is just blatantly false. And now 15, which will wrap this block, is if delta G is equal to 0, then Q equals K.
Yes.
Yeah, that's by definition. If delta G equals 0, we have reached equilibrium. The free energy drives all processes towards equilibrium, the Le Chatelier's principle, and at equilibrium, Q, which is the reaction quotient, is equal to K. In fact, K, which is the law of mass action or the equilibrium constant, is the value of the reaction quotient at equilibrium. So we just restated the same thing 3 different ways. And this is true. Okay. That's a wrap for block 10 through 15.